Alright guys, starting our last unit for discrete is 7.1 linear equations. So we're taking it way back to math 1. Alright, so we're going to start right here with a linear equation in two variables. It's an equation that can be written in the form ax plus by equals c. Okay, now when we're looking at this could be an equation that looks like this. Negative 3x plus 1y equals 6. And remember, that's the same thing. If you don't want to write the 1 there, it could be written like negative 3x plus y equals 6. All of that means the same thing. Okay, where a, b, and c are real numbers. Let's see if this helps. There. That's a lot better. Where a, b, and c are real numbers and a and b are not both 0. When an equation is written in this form, it's in standard form. So this is the standard form of the equation. Now, a solution for an equation is a number or numbers such that if we substitute them in for the variables in the equation, the result is a statement. The resulting statement is true. Okay, so let's look at this equation, and we're going to ask ourselves, is 315 a solution? So that means we plug in 3 for x and 15 for y and see if this makes a true statement. So we have negative 3. We're going to plug in 3 for x. We're going to plug in 15 for y. We want to know, does that give me 6? So this gives me negative 9 plus 15, which is 6. So the answer is yes, this is a solution. Okay, so I'm going to try another ordered pair. Is 4, negative 6 a solution? So we're going to plug in 4 here. We're going to plug in negative 6 here. And we want to know, does that give us 6? So we have negative 12 plus negative 6. This does not give me 6. That gives me negative 18. So this is a no. This is not a solution. Okay, so solutions of linear equations or ordered pairs x and y of numbers. Okay, so let's look at this right here. And then we have two equations are equivalent if they have the same solution. Okay. So let's look at these two equations. 2x plus 4y equals 12. 4x plus 8y equals 24. If we can get y by itself, let's see what we have. Okay, so the first thing we're going to do is move the x value over. So that gives me negative 2x plus 12. And over here, we're going to move the x value over. So that's negative 4x plus 24. Okay. Then we're going to divide everything by 4. So this is negative 2 over 4. And this is 12 over 4. And that gives me y equals negative 1/2 x plus 3. Here, I get negative 4 over 8x plus 24 over 8. And that's going to become y equals negative 1/2 x plus 3. Okay, notice that these become equivalent equations. So these are equivalent. Okay, now let's see if 2, 2 is a solution. So we're going to plug it into both the original equations. So we do 2 times 2 plus 4 times 2. We're going to see, does that give me 12? So that's 4 plus 8, and that does give me 12. 4 times 2 plus 8 times 2. We want to know, does that give me 24? Because we're using the second equation. So that's 8 plus 16, which is 24. So it does work, and if it worked for one, it should for the other because they are equivalent equations. So this is a solution. Okay? Now, next, the graph of a linear equation is always a straight line. Because if you look at the word linear, the word line is in it. Okay, next, the x-intercept of the graph is where the graph crosses the x-axis. Okay? And the y-intercept is where the graph crosses the y-axis. Now, your x-intercept points because it's hitting the x-axis, that means that there is no y value. So y is going to be 0 because it's sitting on the x-axis. Now, the y-intercept is hitting the y-axis. So that means that it has no x value. Okay. All right, let's look at an example. Suppose you have saved $2,205 to use for living expenses next semester, and that you expect to be $315 per month. Express this information in an equation using the variables R for remaining cash and M for the number of months you're spending the money. Interpret the meaning of the intercepts for the graph of this equation. All right. So if we're trying to figure out how much money we have left, we have $2,205 to start with, and each month we're losing $315. So we're losing $315 per month. Now, if you think in terms of slope-intercept form, which is what we're going to talk about in just a few minutes, your x in this problem is your m, and your y is your r. Okay, so they asked us to find and interpret the meanings of the intercepts. Okay, so the first thing we're going to find is our x-intercept. Remember, for our x-intercept, the y value is 0. So that means that r is 0. So we're going to plug in 0 for r and solve. Okay, so we're going to move the 2,200 $205 over by subtraction. And here, we're going to divide by negative $315. Okay, so that means that M is 7. What did we say M is? The months. Okay, so what does this mean? Our remaining cash is 0, so that means in 7 months, you're broke. Alright, so we got to be very mindful of our money. Alright, y-intercept. To find the y-intercept, our x is 0. So that means that our m is 0. Okay, so this time we have r equals 2,205 minus 315 times 0. So that means the month is 0. So what does that mean? That means that how much money you have at the beginning. Okay, so at the beginning of the semester, you have all your money. Okay? Alright. There we go. Alright. Definition. If x1 and y1 and x2 and y2, so in other words, we have 2 points, okay, are on a line, and our x1 and x2 are not equal, then the slope of the line. So we're talking about slope here. So let's look at slope. Slope is rise over run, change in y over change in x. You subtract your y's over subtracting your x's. Okay? So that's what we have to do. Now, let's talk about positive slope type problems and negative slope type problems. Okay? So positive slope, we could be talking about economist. How is inflation affecting the cost of college education? Okay, so if inflation is increasing, then the cost of college education would be increasing. So that would be positive slope. Negative slope how quickly the town's water supply is being depleted during a drought. Okay, as the drought goes on, there's no rain, so the water supply is going to go down. Okay? Alright, here we go. So this graph shows some changes in the U.S. population from 2000 to 2009. Find the slope of the line. So in 2000, for this population change, for 20 to 29-year-olds, it was 39.9 million. Okay, so in 2000, this is 39.9. And in 2009, it's 41.6. Then down here, for 60 to 69-year-olds, in 2000, it's 20.3 million. In 2009, it's 27.6 million, because that's when the baby boomers were starting to become in their 60s. Okay, so that's why the number increased. Alright, so here we go. So, remember we subtract our y's, y2 minus y1, so we're doing 20 to 29-year-olds, so 41.6 minus 39.9 over 2009 minus 2000. So this is 1.7 over 9, which is approximately 0.19. Now if we do the same for the 60 to 69-year-olds, we do 27.6 minus 20.3 over 2009 minus 2000. That's 7.3 divided by 9. That's 0.81. So what does this data suggest? Well, there was an increase of 0.19 million per year. But this is 0.81 per year. And this is our older population. This is our younger population. So what does this suggest? We need working younger people to support the retiring population. Okay, there's about to be more people retired than working. Okay, so that's why they're worried about Social Security coming to an end and all the good things about that. Well, not good things about that. Okay, next. A linear equation is in slope-intercept form if it is written in the form y equals mx plus b. M is the slope, and b is the y-intercept. Okay? And the ordered pair would be 0B. Oh, it helps if you can see that. Sorry about that, guys. So, a store that rents jet skis has 2 rental plans. In Plan A, the customer pays a base fee of $35. Plan A. Base fee of $35 plus $12.50 per hour. Okay. In Plan B, customer pays a base fee of $22.50 plus $15 per hour. Okay, model each of these plans by a linear equation in slope-intercept form. Graph the equations and estimate what point the rental plan A is preferable to plan B. Okay, so what we're going to do is come up with the equations first. So for plan A, y equals, the base fee is your intercept, y-intercept. So that's your plus $35. Okay, and your slope is what's per, or the part that's changing. So $12.50 per hour. Okay, so that is our slope-intercept form for that one. So for B, customers pay a base fee of $22.50 plus $15 per hour. So this one would be 15x plus $22.50. Now we're going to take it back to your graphing calculator. So we're going to graph on calculator. Okay, so go into y equals, type in both equations. Okay, so we go to our calculator. So we go to y equals, we type in 1250 plus 35. Oh, 1250x plus 35. Okay, then we come down and type in 15x plus 2250. Okay, and you can put the zeros in there if you want. Okay, then you're going to go to graph. Okay, and I'm going to hit zoom, and I think zoom 0 is zoom fit, so that way you can actually see it. Now we need to know where those two cross, because we need to see when this second line overtakes the first line. So we're going to go to second, calculate, and do 5, intersect. And we need to try to get something below and then something above. So when you click something below that intersection, you hit enter, and then it's going to go second curve, so go above the intersection, hit enter. Then you're going to hit enter, and it's saying that it will intersect at 5 and 97.5. Okay, so I'm going to write here, you go second trace, which is the calculate. You're going to choose option. What option was that again? 5. And you're going to go and hit enter below intersection and enter above intersection. And then hit enter again. So that intersection is going to be 5 and 97.5. So that means plan A is preferable to plan B. Plan A is preferable or preferable to plan B at 5 hours and a cost of $97.50. Okay? And that's all there is to it. All right, if you have any questions, let me know. Have a good day.